A gardener walks into the garden carrying a small brown bottle that looks like it belongs in a medicine cabinet, not next to tomatoes, peppers, herbs, flowers, or houseplants. A few drops go into a spray bottle. The mixture gets sprayed onto leaves, or poured directly into the soil, and then the claims begin. Some people say hydrogen peroxide can save dying plants. Others say it cures root rot. Some insist it kills fungus, boosts oxygen, disinfects soil, and transforms struggling gardens almost overnight. Then another group of gardeners warns that it burns roots, damages leaves, harms soil life, and creates even bigger problems. So who's right? Why are gardeners spraying hydrogen peroxide on plants in the first place? And what actually happens when that familiar bottle touches leaves, roots, fungi, microbes, and soil? The answer is more interesting than most videos make it sound, because hydrogen peroxide is neither a miracle cure nor a gardening disaster. It is a tool, and like any tool, whether it helps or hurts depends entirely on how, when, and why it is used. Today, I'm going to separate gardening folklore from garden biology and uncover the truth most videos skip, because the bubbles are only the beginning of the story. Hydrogen peroxide became popular in gardening for a simple reason. Most people already have it. You can find it in grocery stores, pharmacies, supermarkets, and discount stores almost everywhere. It is inexpensive, it feels familiar, and perhaps most importantly, it sounds scientific. Gardeners often hear that hydrogen peroxide contains oxygen. Plants need oxygen. Roots need oxygen. Therefore, more oxygen must mean healthier plants. At least that is the logic many people follow. Then comes the visual effect. Pour hydrogen peroxide onto soil, a dirty pot, or a damaged plant surface, and it often begins bubbling immediately. Those bubbles look dramatic. They look active. They look like something important is happening. For many gardeners, that bubbling creates a powerful impression. It feels like medicine working, and that feeling helped fuel thousands of videos, articles, and gardening discussions over the years. Before long, hydrogen peroxide became associated with almost every common plant problem. People started using it for fungus, root rot, seed starting, mold, algae, gnats, wet soil, garden sanitation, and even as a routine plant health treatment. But here's where the story becomes complicated. Some gardeners reported success. Others reported damaged roots, burned leaves, stressed seedlings, and disappointing results. And this is why two gardeners can use the same bottle and get completely opposite results, because hydrogen peroxide is doing something very real, but not always what people think. To understand why, we need to understand what hydrogen peroxide actually is. At first glance, hydrogen peroxide looks almost identical to water. Clear, colorless, simple. But chemically, it is different. Water is made of 2 hydrogen atoms and 1 oxygen atom. Hydrogen peroxide is made of 2 hydrogen atoms and 2 oxygen atoms. That extra oxygen atom is what changes everything. It makes hydrogen peroxide highly reactive. Think of it like a molecule that doesn't want to stay together for very long. Eventually, it breaks down into ordinary water and oxygen. That sounds harmless, and eventually it is. But before it breaks apart, it can react with living tissues, microbes, enzymes, and organic matter. Scientists call this oxidation. Oxidation can damage cells. It can disrupt microorganisms. It can alter biological structures. This is exactly why hydrogen peroxide is useful as a disinfectant. It helps damage unwanted microbes on surfaces. But this is also why gardeners must be careful, because fungi, bacteria, algae, root tissues, and leaf tissues are all made of living cells. Hydrogen peroxide does not always distinguish between the cells you want to affect and the cells you want to protect. This is where hydrogen peroxide stops looking like a miracle and starts looking like chemistry. And chemistry does not care about gardening myths. It follows reactions, which brings us to the most misunderstood part of all, the bubbles. If you've ever poured hydrogen peroxide onto something dirty, you've seen the foam, the fizzing, the bubbling, the dramatic reaction. Many gardeners assume those bubbles are proof that healing is taking place. But the reality is more nuanced. Hydrogen peroxide reacts with enzymes naturally found in living tissues and microorganisms. One of those enzymes rapidly breaks hydrogen peroxide apart into water and oxygen. That reaction creates visible bubbles. The bubbles can appear when hydrogen peroxide contacts microbes. They can appear when it touches organic matter. They can appear around damaged plant tissue. They can appear in soil rich with biological activity. But here's the important lesson. The bubbles look like medicine working, but in the garden, bubbles only tell you that a reaction is happening. They do not tell you whether the plant is being helped. That distinction matters because many gardeners see bubbling and immediately assume success. Yet bubbling alone tells us nothing about the final outcome. A strong reaction can happen while roots are being stressed. A dramatic foam can appear while beneficial microbes are being disrupted. A bubbling surface can look impressive while the real cause of the plant's problem remains untouched. The bubbles are evidence of chemistry, not proof of healing. And once you understand that, many viral gardening claims begin to look very different. Now for the part that often gets lost in online arguments. Hydrogen peroxide does have legitimate uses in gardening. The key is understanding where those uses begin and end. One of the most useful applications is cleaning. Garden tools, trays, containers, seed starting equipment, and reused pots can all carry microbes, fungal spores, algae, and organic residue. Properly used hydrogen peroxide can help sanitize these surfaces. In this role, it makes perfect sense. You're treating an object, not trying to manage a living ecosystem. Hydrogen peroxide can also help reduce some surface-level fungal issues under certain conditions. Notice the phrase surface level. That distinction is important. When fungal growth exists primarily on exposed surfaces, hydrogen peroxide may help reduce some of that growth. It can also help remove algae or slimy buildup that develops on trays, containers, and other non-living surfaces. Seed starting equipment is another situation where careful sanitation can be beneficial. Young seedlings are vulnerable. Clean equipment can reduce certain disease pressures before they become established. There is also one situation that generates enormous debate: overly wet soil. When soil becomes saturated, oxygen levels drop dramatically. Hydrogen peroxide can temporarily release oxygen as it breaks down. In some emergency situations, this may provide a short-lived boost. But notice the wording: temporary, short-lived, emergency, not routine, not weekly, not a substitute for proper growing conditions. And that difference becomes critical when we start talking about fungal problems. One of the biggest mistakes in gardening is treating every fungal issue as if it were the same problem. It isn't. Powdery mildew on leaves is different from damping off disease in seedlings. Root rot is different from harmless surface mold. Leaf spots are different from fungal growth on potting mix. Yet many videos lump all of these together. Hydrogen peroxide gets presented as a universal fungal solution. The reality is far more complicated. Imagine two gardeners. One has powdery mildew developing on leaves because plants are crowded together with poor airflow. The other has root rot developing because containers stay waterlogged for days. The visible symptoms may both involve fungi, but the underlying causes are completely different. Hydrogen peroxide might affect some fungal growth on the surface, but it does not fix stagnant air. It does not improve sunlight. It does not create drainage. It does not reduce overcrowding. It does not correct watering habits. And this is where many gardeners become frustrated. The treatment seems to work for a few days. Then the problem returns, because the fungus was never the real cause. The fungus was the symptom. The environment was the cause. Healthy gardens are not built by constantly attacking symptoms. They are built by improving conditions. And nowhere is that lesson more important than with root rot. Root rot has become one of the most common reasons gardeners reach for hydrogen peroxide. And on the surface, the logic seems reasonable. Roots are suffering from low oxygen. Hydrogen peroxide releases oxygen. Problem solved? Not quite. Root rot usually develops because soil stays excessively wet for too long. Water fills the spaces that should contain air. Roots begin to suffocate. Beneficial processes decline. Opportunistic pathogens gain an advantage. The plant weakens. By the time symptoms become obvious, the root environment has often been unhealthy for quite a while. Now comes the hydrogen peroxide treatment. A gardener pours it into the soil. Oxygen gets released. Some microbes may be affected. For a short period, conditions might improve slightly, and sometimes the plant appears better. But here's the critical detail. Hydrogen peroxide does not cure bad drainage. It may buy time, but it cannot replace oxygen moving naturally through healthy soil. The real cure for root rot is not a stronger bottle. It is a better root environment. If excess watering continues, root rot returns. If the soil remains compacted, root rot returns. If drainage holes are blocked, root rot returns. If containers remain waterlogged, root rot returns. The bottle was never the long-term solution. The environment was. And once gardeners understand this, they stop looking for stronger treatments and start creating healthier root zones. Now we reach the point where helpful becomes harmful, because the biggest mistake gardeners make is not using hydrogen peroxide once. The mistake is turning it into a habit. Hydrogen peroxide is reactive. That is why it works. But that same reactivity creates risk. The same reaction that attacks fungus can also attack tender root hairs. The same bottle that cleans a tool can disturb living soil. In gardening, disinfecting everything is not the same as healing everything. Healthy soil is alive. It contains bacteria, fungi, microorganisms, tiny biological interactions that support plant growth every day. Many gardeners focus entirely on eliminating harmful organisms. But healthy gardening also depends on protecting beneficial ones. Overusing hydrogen peroxide can disrupt that balance. Tender seedlings are especially vulnerable. Young roots are delicate. Fresh growth is sensitive. Repeated applications can create stress that gardeners mistakenly interpret interpret as disease progression. Then they apply more, and the cycle continues. The problem is not necessarily the bottle. The problem is forgetting that plants live within ecosystems. Even a pot on a balcony contains a living community beneath the surface. Many gardeners assume spraying leaves and pouring soil treatments are basically the same thing. They are not. Leaves and roots experience hydrogen peroxide differently. Leaves have protective surfaces, but they can still be damaged. Strong solutions may create spotting, discoloration, or tissue injury. The risk becomes even greater during hot weather or direct sunlight. Moisture, heat, and reactive chemicals rarely make a good combination. Soil presents a different challenge. Soil is alive. When hydrogen peroxide enters the soil, it interacts with microbes, organic matter, roots, and countless biological processes. That complexity makes soil applications more delicate than many people realize. Hydrogen peroxide should never become a routine watering habit. It should not replace regular irrigation. It should not become part of weekly feeding schedules. It should not be viewed as a plant drink. Instead, think of it as a targeted tool, a specific response for specific situations. Used carefully, used thoughtfully, and used far less often than many viral videos suggest. If a gardener chooses to use hydrogen peroxide, caution is the smartest approach. Start with ordinary household hydrogen peroxide that is commonly sold at 3% concentration. Avoid stronger concentrations unless you have specific expertise and understand the risks involved. Always dilute appropriately before application. More is not better, stronger is not safer, and faster reactions do not guarantee better outcomes. Test any treatment on a small area first. Observe the plant. Watch for signs of stress. Give the plant time to respond before expanding treatment. Apply during cooler parts of the day. Evening or shaded conditions are generally safer than intense midday sun. Never combine hydrogen peroxide with vinegar, bleach, fertilizers, pesticides, or other garden chemicals unless you fully understand the interactions involved. Mixing chemicals casually is never a good gardening strategy. Most importantly, identify the cause of the problem before reaching for any treatment. If poor drainage caused the issue, fix drainage. If overcrowding caused the issue, create space. If poor airflow caused the issue, improve airflow. Hydrogen peroxide should never become a substitute for diagnosis. Less is usually safer, and if a plant begins showing signs of stress, stopping is often wiser than continuing. There are situations where hydrogen peroxide is simply not the right tool. Plants already suffering from drought stress are poor candidates. Those plants are already struggling. Adding another source of stress rarely helps. Very young seedlings require extra caution. Their tissues are tender. Their roots are fragile. Healthy soil rich in compost and beneficial life usually does not need routine peroxide treatments. In fact, many thriving gardens succeed precisely because they support biological diversity rather than constantly sterilizing it. Avoid spraying plants during hot, sunny weather. Avoid using hydrogen peroxide as a preventative treatment on every healthy plant. Avoid treating it like fertilizer. Avoid treating it like a growth booster. And never use it as a replacement for proper gardening practices. It cannot replace drainage. It cannot replace pruning. It cannot replace spacing. It cannot replace fresh potting mix. It cannot replace correct watering habits. A bottle cannot compensate for an unhealthy growing environment. Before reaching for hydrogen peroxide, there are usually better first steps. Start with airflow. Many plant problems improve when air moves freely around foliage. Remove heavily diseased leaves when appropriate. Reduce sources of infection. Inspect drainage holes. A surprisingly large number of plant issues begin there. Refresh compacted potting mix when necessary. Healthy roots need both moisture and oxygen. Water less often if plants are staying wet too long. Focus on watering correctly rather than watering frequently. Clean tools regularly. Separate infected plants from healthy ones when disease appears. Support healthy soil with compost and balanced growing practices. Encourage resilience instead of constantly sterilizing the environment. Most garden problems become easier to manage when conditions improve, and improving conditions is usually cheaper, safer, and more effective than chasing one treatment after another. Hydrogen peroxide remains one of the most misunderstood bottles in gardening. Its popularity makes sense. It is affordable, accessible, familiar, and sometimes genuinely useful. But usefulness and magic are not the same thing. The bubbles can be impressive. The reactions can be dramatic. The before and after stories can be convincing. But gardening rewards understanding more than excitement. The best gardeners learn to ask a different question, not what can I spray, but why did this happen? Because once you understand the cause, the solution often becomes obvious. Sometimes hydrogen peroxide has a place. Sometimes it does not. The wisdom lies in knowing the difference. The garden does not always need to be sterilized. Most of the time, it needs balance, air, patience, and living soil. And the gardeners who understand that truth usually end up with the healthiest plants of all.